Good morning, good afternoon, wherever you may be. We are so glad that you could make it to today's Training Tuesday. For those of you who are first-time visitors to our Training Tuesday, I am Heidi Reese with Dayton Superior's Marketing Training Department, and just want to go over a couple of minor housekeeping for the webinar today, like normal. Everyone who has joined the call has been muted so that there aren't any disturbances around, and you don't hear dogs barking, planes flying over, that kind of thing. But you are more than welcome to send any questions that you might have on the chat functionality through the Zoom application, and we will have a question and answer session at the end. And then from there, you can know that it's being recorded, so anybody who might benefit from it later on could go ahead and utilize the webinar. It will be posted to DaytonSuperior.com as well as our YouTube channel. Okay, so what are we talking about today? We're going to be talking about the DB and DI Dalbar. It's a 101, so we're only going to get a brief overview of the different forms of splicing methods for this. We're also going to be talking about the different splicing loads as well as the yield strengths that happen with that, a basic overview of the system, and a couple more things. So today with us, so excited, we'll be led through this DBDI Dalbar 101 with our own National Training Manager, Mr. Chuck Hoke. So super lucky to have Chuck here. He's very knowledgeable and he helps our team and customers understand all the different areas and products of the business. Always willing to take the phone call, always helpful. I just love Chuck. Many of you know him from the role he holds as, like I said, the Dayton Training Manager, but he's been with the construction industry for over 48 years, and he's been a dealer, sales, product manager, and more. And as I sit here across the room from him, he's turning red because he doesn't like me to talk about him this way. But he is a wealth of knowledge, and he is ready to present us with the DBDI for this coming Training Tuesday. So Chuck, go ahead and, well, I can say the training presentation is just that. It is a presentation for training purposes. Anything that you see within the presentation is any kind of technical data. You can go to DaytonSuperior.com and look up safety data sheets, technical data sheets, and product information there. All right, now, your turn, Chuck.
All right, thank you, Heidi. Today, as Heidi alluded, we are going to be talking about DBDI, our Dalbar substitute, the DB-SAE, Dowel system. So let's start with a little bit of basics here. When we talk about lap splice, how do you actually splice rebar? You have a couple of different options. The first one is lap splicing. That's where you're going to take two pieces of rebar, overlap them, and tie them with rebar. You have the option of welding if you use A706 bar. If you use A615, you cannot weld because welding is not recommended with A615. You can do it with A706 rebar. And the last option is mechanical. Mechanical is probably becoming one of the more preferred methods of splicing versus the lap splice and as far as any of the other options we have here. Because with mechanical splicing, we have three different options. We can go with a threaded system, a swedged system, or a bolted connection system. And we're going to talk a little bit about those as we move through here. The lap splice, as we see, here's what it typically is. You're relying on the interlocking of the ribs on the rebar being held in place with two pieces of 16 gauge or 16.5 gauge tie wire. Not actually one of the more stronger systems in the marketplace. So here we have our two rebars, the lap length. Typically the lap length is determined by a figure from CRSI. CSI will come back and tell you they want for a required strength. And the rebar, you're going to have to have a select development length or bar diameter OLAP. So a lot of times they'll say they want a 40 bar diameter. So if you have a 1/2 inch rebar, you're going to have a 20-inch lap. When we're dealing with a welded splice, you're taking your 2 pieces of rebar, setting them in place next to each other, and then obviously constructing a weld. Not the most economical or most used system in the marketplace. You don't see this really used a whole lot anymore. And once again, this also has to have a development length of bar for the overlap. Now, on the mechanical end of it, we're going to talk a little bit of the bolted system. We were fortunate, we actually bought a company back in the early 2000s called Barlock Company. And Barlock actually produces a coupler, a bolted connection coupler, basically, that uses shear bolts that actually penetrate the rebar and cause the rebar to engage some rails in the bottom of it to actually gain the strength of the rebar. So it's a non-lap splicing rebar connection. And the bolts, once they shear off, you know you have permanent connection. Your connection is actually completed. The picture on the bottom of the swedge system is one that actually is less commonplace in the marketplace, especially in the field related. You see sometimes it's done in the shop, but typically in the field, you don't see a lot of swedge anchor systems going in place here, primarily because you had to have some other mechanism to hold the swedge system, or the hydraulic press, while it's wedged on the coupler on the rebar. And then we have a threaded connection. Now, threaded connections came about back in the early 1970s. In 1982, a company called Richmond Screw Anchor developed a system here called the Dalbar splicer system and the USMC threaded system. They actually developed this system. It is a monolithic piece of rebar that has been heated and pressed into position. So everything you see up there's no welding of couplers or anything else to the rebar. It's actually on the DBSAE, everything is 100% rebar. And why are we doing this? Because, well, what we're talking about is with splicing loads, you're looking at rebar. First of all, splicing is usually very good in compression. So that means obviously that pushing concrete together, the compression, you have to have that strength to hold up and keep in alignment the concrete slab. You also have to have the strength for when the concrete wants to expand and move outward. So you have to develop both compression and tension loads with your mechanical splice. And we, the industry, from CRSI, Concrete Reinforcing Steel Institute, they have typically set forth a set of guidelines. We have a type 1 splice, which is defined basically in the current building code as a full mechanical splice that develops tension or compression that requires at least 125% of physical yield of the bar, where the physical yield is specified as the yield strength of the reinforcing bar. So typically, if you have a reinforcing bar that, say, delegates a 60,000 pound PSI, we're saying that the coupler will actually yield 75,000 PSI. So, and then with a type 2, this is defined that the coupler must, according to building code, must meet that of a type 1, but it has to also achieve the ultimate strength of the rebar. So we'll develop the defined specified tensile strength. Rebar typically has a tensile strength of roughly 1.5 times its design load. So the physical yield of the reinforcing bar would typically be, if it was 60,000, the ultimate load would be 90,000. So yield strength, physical yield, the stress to which the limit under the bar will attach a load and basically stretch to a certain point prior to failure, without returning back to its original shape. Yield strength is designated by the symbol of Fy. And once the rebar has reached that point, it has been elongated and stretched and will never return back. So once a rebar is actually fully loaded, it typically is designed, you're going right to the full ultimate of it. The rebar typically at that point does not retain any of its elasticity. So what happens is it will not come back into shape. It will not go back to where it has that flexural strength. As you can see with the yield strength of the different rebar, and these are all grade 60, 86, well, you can see grade 60, grade 70, grade 80, and grade 100 up here for 615 and 706. Both numbers are very similar going down through here. 615 is a lot more common here on the East Coast than in the Midwest. 706 starts in the Midwest and works to the West Coast. It's kind of as the predominant rebar. Doesn't mean that there isn't 706 being used in the East Coast. The 706 is used quite often on a lot of different projects. It's a little bit more ductile than A615. Now, the Dalbar system. It's basically what the system is, basically taking a piece of rebar, putting it into an induction heater and heating it up to about 2,400 degrees. At that point, we run it through a series of presses. This shop here is in Tremont, Pennsylvania. Typically, it is a 4-step press that comes down through, and we'll take the rebar. And what we're actually doing is on our Dalbar, on the Dowel in, the DI, the male section, we are actually compressing the rebar, taking 5 and 4 inches of rebar and compressing it to 3. And basically increasing the overall diameter of that heated area so that it matches the cross-sectional area of the bar. So that way, when we cut the threads into the bar, we no longer infringe on the cross-sectional area of bar that is actually being required to achieve the strength from the rebar. We can do with the hooked bars, we can do looped bars, straight bars and everything are all pretty common. It's a separate fabrication process, but basically the fabrication, as you can see on the D102, you can see where we actually have the threads and they're actually the same size as the rebar itself, the core bar. And if you look at the D101, 102A, the female receptacle, that is all rebar and has been basically enlarged and then tapped to accept the corresponding rebar with that upside thread. Now, typically when we're talking about a construction joint system, to put in place most job sites here, the Dalbar system, basically you take your DB, attach it to your formwork. There are holes in that flange running around the outer edge, and they can you drive a nail through there or a screw to actually attach it to your wood form. You come back, you pour your concrete, strip your formwork, and then you can basically thread in your mail section, your mail bar into the rebar. This now gives you a type 2 connection throughout that joint, so you now maintain that rebar integrity through the joint. We also can do a couple of different things here with the Dalbar system. We have a structural embed anchor system, and the D108 headed Dowel system. The D108 system basically is a female system, basically can be used as a structural embed for any shelf angles, et cetera, that needs to be attached in it, so long as the wall thickness is thick enough. These typically come up to like from about 5.5 to 6 inches and up in length. Same thing with the D108. You can actually have a shorter length with a hex head nut on the end of it. They make a great concrete anchor for anchorage in concrete, and then to tie into. You can tie into the D108 with an NC threaded bolt. So the thread on the inside of this coupling system is NC threaded. Other applications that we can do is our through system applications, both in male and female end of it. These basically are used on where you'll see like Amtrak trains usually use this when they want to have a concrete deck running through a column. They will actually run this through so they can actually attach the rebar from their concrete deck on both the left side and the right side and have a continual run pattern through the structure. You can see here, all female bars have furnished with an integral nailing flange. Sometimes the nailing flange is not perfectly round. Nailing flange is actually formed when they actually pierce the center hole where you're going to actually tap there, and then the hot steel comes out to form up the washer. That washer is not structural. The washer on that face is integral, and it is there for one purpose, to connect the DB to the formwork. Now we can clip that DB if need be, and we do a lot of times for bridge and highway work where customers are looking for concrete coverage. So we will end up clipping the top of the rebar so that we can actually maintain concrete coverage. We can also do end anchors. If end anchors are needed for a project, for columns, et cetera, with either a male or female connectivity with a large headed mushroom head anchor on the end. We do have IAPO approval on all of our products here that we're showing here today. How we actually form that mushroom on the end is basically heating it up again. Attaching a large washer on the end of it is one fashion that we do actually in our Modesto facility. And then what we've done, and we show on the bottom here, that we've actually have bar break capabilities with this system. Basically what it is, the end anchorage eliminates the need for a hook bar. It reduces the engineering the engineering design time and requirements. And also what it does is help remove congestion within the structure itself. As you can see here, some of the typical applications, you see with a forced slab to column, And then you also have a column to beam application for connectivity. What you're seeing here in a lot of structures here, this is one of the next generation beams that's coming out here for bridge and highway, where the beam will actually come in, the beams are put together. The Dalbar is connected to the anchor that's actually cast in the concrete beam, and then the closure pour is completed. You can do this with jump systems. Here's a project here in New York City that was done back quite a few years ago, because this is when I first started in this business. This system here was actually put in place and used on a jump system on a high-rise forming system. They're attaching it here to a recess void, basically to give it a little bit of a keyway, so that when the jump system moved up, they came back, slide the keyway off of it, and then poured their floor slab right at that elevation. The biggest thing for DBs where we're seeing it used is with concrete formwork. Basically, we're stop customers from punching holes within the concrete formwork, because it never seems, they always seem to find that brand new form. And that's the one they want to put the big hole in to make it run their rebar through. So this system actually has helped a lot of contractors and form manufacturers maintain their fleets a little bit longer. As you can see, the system here is attached to the formwork. Sometimes they'll put duct tape on them. In today's marketplace, we've actually attached now a metal washer on over the threaded area that can be removed with a hammer and screwdriver, so that way no concrete can get into it. And when you apply it to your formwork, you strip your formwork, you then have your pattern here from your rebar, you then make your attachment with your dowel ends into it. And you can see you can do a wide array of different attachments with it. We see this is a clarifier in a wastewater treatment plant. You can do the same type operation with corbels in a parking structure, etc. Once this is all formed up, it will actually create the system for pouring your concrete, making the pours much easier on the contractor. For resources, obviously DaytonSuperior.com is a great location to start. You have all the contact information, technical data sheets on here, who to call. We've also got the, I'll call spreadsheets that are available so you can actually fill out. It's an order form for Dalbar sub. We have them for about 8 or 10 different products that we typically carry. They make life a lot easier. You can get it on the DaytonSuperior.com site and print it off and then send that over to customer service to get your order straightened out. Also have product pages available, handbooks available, and basically all certifications that will be required by DOT and other agencies.
That's awesome, Chuck. I also want to put in a blurb because we just got Ontario. We're the first company approved for the Ministry of Transportation
MTO.
For these products, MTO. Yeah. So from a marketing perspective, we want to let you know about that. And also, we have a Superior deal going on right now. Just started this today, and it's only for the month of November, and it is on the D101s and the D101As. That's the Dowel and the straight Dalbar splicer. It is not on configured to order or made to order products, but it is on all of the ones that we have in stock for you. And just contact your sales representative for details, and we have special pricing for that. So Chuck, do you have anything else to add, or are you good?
We're good, thank you, Heidi.
Yeah.
If anybody has any questions, we feel free to add them to the page right now.
Yeah, go ahead and put it in the chat functionality.
Chat functionality, and we will reply to them.
All right, so as we're waiting on you guys to enter the questions, if you have any, just a reminder that we do record these and let you know when they're available to you to download, listen again, forward on to a friend. Sounds like a game show, doesn't it? Forward on to a friend, call a friend. They will be placed on DaytonSuperior.com as well as our YouTube channels for Dayton Superior. Any questions? All right. Well, Chuck and I both appreciate you guys joining. Remember, we have these every Tuesday at 1. Oh, thank you. So someone said, thanks, a great explanation. I think that Chuck does a great job with that. So I appreciate the feedback there. But again, we have these every Tuesday with different topics. Next week will be taper lock, right? And yep, for splicing. And yeah, I'll send you an email about it and you can sign up and love to have you there. So with that, everybody have a very happy Tuesday and we'll see you next time. Thanks.